Hello, welcome, and thank you for attending our exciting panel on navigating the fragmented security landscape for security hardware design. I'm Wayne Dragon, Global Technical Solutions Manager for Aero Electronics out of our headquarters in Denver, Colorado. We've assembled a panel that has experience in our customer base and the vision that can help guide embedded customers through secure designs from sensors to cloud, including views from hardware and software, also including standards and certification. As I do the intros for the panel, go ahead and give a wave so people can put a face with the name, and I'll go ahead and walk through our distinguished guests. So I'll be your host today. And again, my name is Wayne Dragon, just like the mythical creature, and I focus on secure end-to-end technology solutions, really driving new business outcomes and better customer experience. I have over 26 years of industry experience and about 20 years at Aero, and I've had a lot of roles throughout the time here, and really now I'm concentrating on security and low power wireless. So I like to say that I've been working on IoT since before it was cool and it was still known as M2M. I'm guessing a few of our panelists were probably working on it during this time as well. So for fun on the weekends, you might see me helping with my 3 children's activities, everything from coaching American football to helping leading scout adventures. So our first panelist is Erik Wood, Director of Microcontrollers Security. Erik, give away, there you are. And he's at Infineon Technologies. Erik spent the first 14 years of his career at various wireless sensor network startups. He joined Infineon through Cypress and Ramtron acquisitions. At Cypress, Erik started out working on FRAM technology for passive RFID and secure memories and was pulled in to run the product line for secure microcontrollers and differentiated security software. Erik developed his passion for IoT security working for famed cryptographer Dr. Whitfield Diffie in a startup whose mission was leveraging innovative technology to secure resource-constrained ICs. He's a passionate believer that security is not just a thing, but instead it's a mindset, similar to quality. And that it requires constant application in all aspects of life. And, his wife still loves him for it, and maybe in spite of it, or maybe both, I'm not sure. So next up on our panel, Phil, give a wave. Phil Attfield is CEO of Sequitur Labs. Phil brings a strong background in computing, networking, security, and systems modeling. He's more than 20 years experience in large enterprises and small entrepreneurial firms. Starting his career at Northrop, Phil was a member of its scientific staff. Later, Phil founded Signal 9 Solutions, a firm that pioneered PC desktop firewalls and created the Conceal brand of security products. Phil served as the CEO until the company was acquired by McAfee during a rapid broadband expansion phase of the internet. Phil then joined Phantom Works R&D division of the Boeing company, where he led the team responsible for the development of a large-scale security policy and management framework. Phil has a love for radio technology and has been fixing tune radios in his spare time. So he's got an alignment with Aero with our starts in the radio industry. So if you need a hookup for vacuum tubes, Phil's your man. Next up on the panel, Anurag, give a wave. Anurag Gupta is the Business Development Director of Platform Security Architecture within the Architecture and Technology Group at ARM, based in Cambridge. Anurag brings over 19 years experience working in the semicon industry, doing embedded and services. He specializes in business transformation with technology and innovation with focus on the Internet of Things. As we move towards a connected world, device level security has an increasingly important role in bringing together the Internet of Things, connecting objects, people, and services all around us. In his role at ARM, Anurag focuses on PSA certified initiative in order to raise the bar of security within the ecosystem. And before joining ARM in 2019, Anurag held a number of roles at Connexent, Sasken, and Accenture. Anurag is fresh back from holidays, ready to help out on the panel, where on holiday, he was sleeping in tents next to wild animals in a resort that saves and takes care of endangered animals. Pretty cool. I would have went with the tree fort versus the tent, but that's all right. So he's also a volunteer police officer in the UK. So he's associated with security both professionally and personally. Last but not least, Carlos, give a wave. Carlos Serratos is joining our panel. He's the Senior Director of Strategy, Policy, and Advocacy at Brightsight. He's a specialist in IoT security and compliance. On his role, he engages with policymakers, regulators, and industries across verticals and regions, addressing trust enablement issues for compliance, risk management, and accountability purposes. He's a board member and director of the IoT committee at Eurosmart, co-chairing the IoT Security WG5 at the Global Silicon Alliance, as well as Security Task Force and CSIP Subtask Force under Global Platform. There's tons of experience here. And Carlos, little known fact, is our extreme sport athlete in the crowd. You won't see him on the X Games just yet, but he has a 15-year-old son that enjoys pushing him extremely during COVID. A few weeks ago, he participated in an obstacle course racing on muddy trails. They hit the gym together. Yesterday, they asked to go cycling after dinner. So now Carlos is currently recruiting and looking for a new friend, a girlfriend, somebody else that will be his son's extreme partner. And until then, I think we might expect to see Carlos entered in some Spartan races. So when we look at security and we see all the links in the chain of security, I think about it from a sports aspect of looking at a pitcher and the links in the chain. And there's so many different things that you need to do as you go through the links in the chain and get started from, it's not just about arm strength or grip of the ball or rotating your core. It's also about foot placement. There's all those links in the chain that make for someone be able to throw a strike. And I see that in security too. Security is so complex as our connectivity has gotten and raised the bar for the different features that are out there. We also increase the attack surfaces. And just like baseball, security is going to have strengths and weaknesses, and you're only as strong as the weakest link in that chain. So with our team, we're ready to talk about the security industry and really how it's affecting our embedded customers. So before we get started and go to the panel, I would like you to use your Q&A as attendees of the panel and give us a feel for your confidence level. If you are getting ready to put together secure embedded systems and devices on a scale of 1 to 5, 1 being not confident at all in security, and 5 being bring on the attacks, we're ready, what would you put? Go ahead and put that in the Q&A and would like to see your answers. So I'd like to set up the panel discussion by looking at a historical view, looking past to see where we're going in the future. If you wanted to go across our industry and say in the last 5 to 10 years, what is the state of embedded security? And I think this one, I'll tee up for Erik to start, and I'd really like to get your view as a silicon provider, Erik.
Yeah, thanks, Wayne. So really interesting question. I think back to my own experience getting started in IC security in 2010 with Dr. Whitfield. And really our mission there was to take these very small resource constrained NFC chips, UHF, RAIN, RFID chips, 16 and 32-bit microcontrollers, and implement very robust security. And what's interesting is then you had a complementary security posture for devices that would go into PCs and the furthering of smartphones. And so there was this kind of spacing, and as that matured, and recently what we see is the middle ground between that from a compute power called microcontrollers, not microprocessors and not RFID chips, but the middle ground microcontrollers are harvesting quite a bit of benefit from looking at how security was done on the more advanced life forms of microprocessors and the lesser advanced life forms of RFID chips. and finding how to take that experience and excellence and apply it to the 32-bit microcontroller space, where on one hand, compared to a microprocessor, you're wounded with far less resources, and from an RFID chip, your system is much larger from an attack surface. So it's really compressing the skills and insights and lessons from those well-mature spaces, like we've done at Infineon on the lower life form size, and bringing that super robust security into an SoC, the higher life form with a larger attack surface.
Yeah, definitely makes a lot of sense in how we kind of look at it and, the build over the history. Hey, Phil, from Sequitur's perspective, you guys have software and services. What are you seeing, and how have you seen the trends in history?
So with a background coming from telecom and aerospace, I've worked in, call it, highly regulated industries. And one of the things we encounter is sort of the maturity of the enterprise that's producing the product or going to release it into an ecosystem. And I mean, security is not a technology, it's not a product. There's a solution in there somewhere, but it's actually a set of complex interlinked processes. And if you think about it, it starts with selection of the silicon, and before that, even the requirements of what the system has to fulfill over whatever its lifespan or service lifespan might be. I mean, we encounter soup to nuts, and it's a matter of, I'll say at the end, it's company maturity and them realizing what is the risk that the system is going to be exposed to, what is the environment that it will reside in, and what steps can be taken. There's a lot of lessons that can be learned from other regulated environments. And fundamentally, there's a lot of discipline, there's a lot of test and a lot of process involved. It's sort of, I'm hopeful it's been done before. It's been done going back 40 years. We can learn from other industries. It's just look elsewhere and work on it, but it takes a lot of discipline.
It definitely makes a lot of sense. And, that angle from different markets and how we address risk, it definitely makes a lot of sense. Carlos, when you look at it from your standpoint and you see it from customers and the organizations, you guys deal a lot with, certifying designs and, looking at it from design concepts with security in mind. Where do you see the history? How has it really come in and affected your business and your customers?
Let me give you the answer in two parts, because a lot of things that you mentioned so far makes a lot of sense or resonates a lot with what we do. The first part is that we do a lot of security evaluations on domains where security is on a high level. Okay, that's where we're coming from. Like Phil mentioned before, there are already industries that are well established and there are best practices out there. But as we move closer to the IoT, we see an evolution there. We see a different aspect of security with regards to what the developers bring. We see that there is not enough expertise. There is the focus is somewhere else. IoT developers focus their capabilities somewhere else, not necessarily in security. We see that digital maturity plays a very important role. We still see a lot of products that come to the market with analog processes attending a digital market. And then we see also skill gaps. So we don't have enough professionals in the area of security. And when you get close to those IoT markets, to the emerging markets where security was no primary focus as we do in the other domains, is that we see those changes. Now, the other dimension of this answer has to do with the fact that we see different layers. We see from the design, the silicon vendor, the software provider, the system integrator, software provider, all the way to the end device. And it's very interesting to see that we bring a lot of security capability from the experts, from people who really focus on security. And that enables the IoT developers, the people who's going to be using those embedded systems, to make use of that security capability. So that compensates for all the other issues that we mentioned before, the digital maturity, the skill gaps, the security expertise. We are not there yet. I think it's still, we have a long way to go, but we see that working. And we see already some evidence that is making good use of that expertise for those markets where we don't have the security capability yet.
Yeah, Carlos, I couldn't agree more. And you see that across the industry and customers with skills gaps and knowledge gaps, right? That we have to fill in to make sure we're providing secure devices and systems, right? Last but not least, I'd really like to get Anurag's opinion as well. I mean, you've heard from the other panelists and how the IoT stack goes from chip to board to firmware and applications. We talk about software and cloud and storage. It goes through the full life cycle of these devices that are out on the market from, a few years to 10 plus years in industrial. Like where Anurag, do you see OEMs being most vulnerable to attacks?
Pretty interesting question, Wayne. I would say that Erik and Phil already touched on the technical side, which includes resource constraints and best practices. And if you're okay, I would like to answer it not technically or more from the business angle side of it.
Please.
So I think the answer is OEMs are most vulnerable to their brand, to their reputation. So I would say that the organization is most vulnerable because if it's attacked or hacked, then they suffer brand erosion, they have got reputational damage, and they also run the risk of litigations, right? So now if you see from another angle, in order to bring all the components together and make use of a root of trust in products, life cycle is a big challenge for OEMs, because OEMs, if you see, sometimes they act a bit like a system integrator. As they don't develop their own silicon, they probably don't develop the IoT stack. And they certainly don't develop the cloud services, but they build and are responsible for the final product. So I would say that they sit somewhere in the center of the whole ecosystem. And even though 80% of the technology has nothing to do with them, but their brand and their corporation will suffer. So I strongly believe and suggest that it's an interesting and a very important angle that we need to think about.
Yep. Thanks, Anurag. I couldn't agree more on that. I mean, when we come through and you're looking at it, there are those risks and there's the real costs that come through it. So I think the business perspective is big because you have to do the balance as you're developing devices. You're looking at the market and the reputation and all the things that you have there. So appreciate the insights, everyone. And I think the next question I'd like to spend some time on is when we look at the security industry, we talk to our customers and our OEMs, and it's really confusing out there. There's a lot of standards and certifications, and that market seems very fragmented. For global OEMs that want to sell throughout the world and from region to region, how do you see those requirements, and how do we address that fragmented market? I think, Anurag, I'd love to have your thoughts on this, kind of touching on that.
Yeah, I would say I have been talking to various OEMs globally, and one of the topic which keeps coming is fragmentation around standards and regulation. I would say that fragmentation is not only regionally, but it also industry-wise. So what I mean by that, if we look into various regions, we have got various regulations, like you talk about NIST 8259, you talk about state California and US. And when we come towards Europe, you have got HC 303645, then draft UK DCMS, and Nordics have got their own. And same way, if we go towards APAC, we have got Cyber Security Agency of Singapore, and then we have got METI, which is the Ministry of Economy, Trade and Industry in Japan, which releases their own IoT security and safety framework. And it doesn't stop here. Now, if you go into various industries like automotive, they will have their own regulation like UNECE vehicle regulation, which is WP29. And then you also talk about ENISA. And same way, you talk to industrial guys, they start talking about ISO and IC 62443, and smart cameras guys will talk about OSA, and then medical have their own. So I would say that there is a serious need of defragmentation around this fragmented landscape of standards and regulation. In fact, I would say PSA certified is doing exactly the same, that is bringing defragmentation as well as aligning and mapping with various standards and regulations with a clear intent to make it easy for OEMs to consume and implement.
Yeah, Anurag, I think that's a great point. And Carlos, from your SGS and Brightsight standpoint, I mean, this is the daily challenge I think that you're living with, from a testing standpoint. Can you give us some insights on how you test to different standards and what people are coming in with?
Yes, sure. And I think to start with, one of the very important drivers, perhaps the most important driver in this industry and the testing and inspection certification industry, is regulatory compliance. That's a fact. And that's important because many times this translates as access to market. That's the set of verifications of controls that manufacturers have to show in order to get access to a particular ecosystem. So just for that reason alone is very important, because that's a very important business driver. Like Anurag mentioned, there are literally hundreds of standards out there. So can give you a very big number that they keep us busy on a day-to-day basis. But one interesting fact is that in one hand, the reason why this is happening, and the reason is because every time there is a breach, policymakers from public and private sectors, they will bring some countermeasures. And they don't bring those countermeasures to make products secure. They bring those countermeasures or those requirements to make sure that we have a trustworthiness ecosystem. We want to prevent that the trust is eroding that particular ecosystem, is this industrial, automotive, etc. So that's important that we have products that we can trust, products, services, processes. Now, on the other hand, if you step back, if you take some distance from the problem, you will see that although there are so many different standards and requirements, the fact is that at the core, they are not that much different. Take, for example, secure communications. If you talk about IoT devices, which the nature of the device is to communicate, it's not a surprise that many of those requirements go around secure communications in different markets and regions. So that's just an example how you can have some core capability, core functionality that can be applied to different scenarios, to different ecosystems and requirements. And that's one of the approach that we see here evolving in the market. PSA is one great example of that, because that security evidence that comes from the core, we can map it against that core capability that will be used later on in specific use cases in different certification programs specific to devices.
Yep. Yeah, and I think as you see, and hopefully as these things start to converge, around those core things that are being checked in each of those certifications and the regulations, it kind of gives us that tighter window so people know where to start. I mean, talking about where to start, I mean, Erik, you from a silicon view, right, you're providing parts to all of these customers. How do you know where to start when you're making secure devices?
Well, I'll tell you, so my answer is going to come through the filter of what my primary role is at Infineon. And regardless of the software teams that I manage and the products I'm responsible for revenue and the business plans and that I need to write, my fundamental number one job is to create the right requirements, as Phil was talking about, the right requirements for the chips we're going to make, right? And hundreds of millions of dollars rely on this, and making sure longevity of the products and the security of our customers rely on that. So to me, that's my most fundamental role at Infineon. And if you think about it from that perspective, what we do is, and Anurag knows this very well because he participated in writing the specification for this, is we do use case analysis. So we take an application, it's going to be a wearable, and we dissect the wearable use case and then organically and bottoms up build up into the security requirements. All right. Now, we do take account the regulatory environment, the industry standards, those all feed into it. The reason I'm framing it in this light is because oftentimes regulators specify outcomes. Don't let the network be hacked. Don't let customers' private information be revealed, confidentiality, right? Well, I can specify that outcome, but I could solve that in many different ways, right? I can solve that with features, a secure boot from a chip, a firmware update, attestation. I can solve that. Then below that, there's the underlying cryptographic requirements. Do you want to use ECC 256 or 384 for your ECDSA operation, right? So then there's the security assurance level. So in security requirements, we have features that support use cases, and then the underlying cryptographic operations that you define from a security assurance level, from a hardware architecture level. Do you have redundant cores to prevent laser attacks? Are you only concerned with logical attacks? Because in the IoT, your biggest risk is somebody accessing through your Wi-Fi connection, not actually having a credit card in their hand to be able to go take the credit card and deprocess the chip and expose, information. So the IoT market is significantly different than the chip card business or the credit card business, because, it's some requirements are coming in, but from a very fragmented market, right? Because you have these different use cases, and I'll tie it back to the use cases. In payment cards, that hardware security is super required. It's a small attack surface. It's just basically a credential. And then you have 10 banks that are defined, and Visa, MasterCard, American Express, that are defining the security requirements, right? There's no, EU defining the payment security requirements as much as Visa, MasterCard, American Express. But in IoT, since it's so fragmented, it's medical, it's security, it's all these different markets, they're trying to prevent outcomes. And then I personally find that, and this is just my opinion, that common criteria does one of the best models, and I'll just say framework or models for applications in the IoT. Because in common criteria, you have security assurance levels, right? You have very clear ways to benchmark those levels. And then the most novel piece is you have protection profiles. And the protection profiles allow you to define for a given use case, IP cameras, wearables, medical devices. We're going to see a proliferation of new protection profiles coming up in common criteria, I believe, because A, they're needed, and B, I believe that is one of the best frameworks. And so now when I see PSA and CSIP aligning, for example, with level 3 to a common criteria AVAVAN.3 level of security assurance, you can pick your PSA profile, PSA lightweight, you can pick your common criteria CSIP protection profile, and now you have a map, right? And then you work with a Brightsight or one of the labs out there to actually, get a, hey, this is how we would attack your device for that given protection profile, for that given security assurance level. And now it's really mapped out. So that's where I see this fragmentation problem getting solved.
Yeah, it definitely makes a ton of sense when you look at it from, a use case scenario and how those attack vectors are going to vary based on what markets and, what those chips are being used for. So for sure. Hey, Phil, from a software and services perspective, right? How can we accelerate, OEMs time to market, when this is so fragmented, how can we help? And, from your perspective, how do you see that fragmentation affecting the business and the customers that you're talking to?
So part of the initial engagement with our customers is to understand the maturity of the organization. And that's between the development teams, between the management, who's responsible for risk assessment, who understands what the liability is of even putting the system in the field. And quite often we get asked about, what about certifications? We go, well, what do you think you need? And do you understand why you're even asking? So to take that and map it straight back to the system requirements and the operational requirements and the lifespan of the device. And we have customers that put devices in the field for 50 years. We've already dealt with the 2031 bad certificate overflow problem. So there's another problem coming. Certs are going to explode January 19th, 2031 because the dates roll over. We identified that in their system. They didn't even know it coming. Their CA couldn't deal with it. So you go from the specification, then typically there's some legacy or offsite manufacturing. If you're dealing with credentials at a root of trust, they don't want to pay $1 a device. Credentials are absolutely worthless. They're worth nothing. It's just a piece of information. So they want to minimize the expense and the cost. Dealing with that across the design phase and the operational phase, if you add $1 up front, that goes into a different budget, and they hate that. You're then stuck with dealing with procurement. If it's going to add 6 months, they need to budget that. If they need to bring in test and certification, they need to budget. All of the costs and all of the processes need to be accounted for. We've had customers where we asked them about key management and they looked at us rather puzzled. And it was, okay, look, this is a maturity problem. And if you step back and look at companies that are already in regulated spaces, they typically already have a team that can deal with this and they have the business processes. What really scares me are the startups that don't have the maturity at all and are fielding products because they're not budgeting for it and they don't know how hard it is. Erik, I'm really glad you mentioned common criteria. I've been on both sides of the table of that. So both as examiner and both as taking products through. And the good part about that, it was backed by treaty 20 years ago when it was kicked off, say May 2000. The great part is that it is a discipline, it's a process, it's manageable, but it's not sort of, okay, so we've built the product, we've got it, they waved the dead chicken and put the rubber stamp on the product. It now goes into life cycle mode and you've got to care and feed for it for the next 20 years. So the processes have to evolve too. And we deal with across international boundaries as well. So, call it the sovereign standard setter, NIST as example, CSA in Europe and in Asia. And the really good part is the standards do align to a set of common principles. And that is a complex map, but it's manageable. It's that's a job for a consultant and somebody with a very detailed map to take and translate. There's probably a PhD in there for somebody to go and work out the taxonomy of language, because that will even vary across industries. What does a requirement map to in one sector through to another? It's hard, but it's manageable. And a lot of it involves education and process, and it takes maturity to get there. They've got to make the investment. And at the end of the day, they have to care enough to make the investment.
Yeah, Phil, when you look at it from a maturity standpoint on the industry, there is a huge range for customers, with experience and what they've done. Are there things that we can learn as a follow-up to, our previous conversation here on this, from certain industries like the payment industry and, industrial gas pumps, where these had high value targets for stealing information, and they were definitely a focus for security early on. Do you think there's lessons learned that we can see there that translate into some of these, industrial markets or newer markets when we go to protecting data and IP?
Absolutely. When you look at sort of one of the initial problems so think back to the origin of payment. Initially, it was offline with a franking machine. Slapped a credit card in, somebody handed you a carbon copy. It was totally offline. Or they'd phone it in and get a number from somebody at the other end of the phone. As soon as the systems go online, it's a problem. And in a lot of IoT, what we're seeing for the first time are systems that have never been connected. They may be networked within a local context, but they're bringing those online or nearline, and all of a sudden the attack surface just went up by 15 orders of magnitude because they're attached to the network. The lessons learned in terms of physical security, network security, even then the entire software and management stack on the device. We have one customer who asked us that we design a set of APIs based on work done a long time ago in authorization and control, was basically to enable a multi-party, multi-tier, multi-tenant ecosystem. And they asked us, how on earth did you ever even consider that this was going to be required in the future? And we said, because it already exists elsewhere. It already exists in telecom. It already exists in aerospace. They've already dealt with these problems. And if you've worked in them, you've seen it and had to go through it. It's discipline and sort of having the foresight of trying to get through this and then dealing at the tail end with this has to go through certification. So if you're taking it for common criteria, start as early as possible and map out as early as possible. Start writing early. Don't lead it to the last minute. It's going to take you 3 years. And by then your competitors have beaten you to market. So start early and invest.
Yeah, it definitely can't be an afterthought when it comes down to those things. As the panel's talking about the different aspects, you think about costs, right? And when you come down to it, there's big costs with being breached, whether it's financial, whether it's time, whether it's reputation. When we look at it, whenever we're investing in new products at OEMs, they do have to look at the costs of development too. Carlos, I want to get your opinion here. We understand there's a cost for services and security, but is there a greater cost to not having this robust security put in place?
I think that still out there this perception of security as cost, right? So most of you will agree that when we start talking about security, they say, okay, this is going to cost me in general. But I will argue that security has value. And like any value need to be cascaded on the value chain. And yes, definitely there are benefits of having security and costs implied when you fail to have security. One thing that is really fascinating about the IoT market is this is the oil of the digital economy, right? So we're talking about transferring data, collecting data, providing services. So if you see it from that perspective, a digital service and being the IoT device an enabler for that digital services, we have seen digital services going out of the market just literally weeks after being breached. Why? Because the entire system or digital service is based on trust, on trustworthiness of the service. For that reason alone, service providers are looking to have trustworthiness on their devices. Think, for example, on service providers. If you see the transactional nature of IoT devices, they're going to be looking to have as many connections as possible, right? So because that generates data. But sometimes they need to find a good balance, a delicate balance between, okay, let's have as many connections as possible, but let's don't expose ourselves too much. Let's don't bring additional risk. So service providers are looking to have also that evidence of security to manage the risk because the implications that a breach has for them. And as you can see, the cost goes beyond to the reputational, and it really can take a service down just for that reason. And that's the extreme case.
Yeah, absolutely.
Systemic.
Yep. Agree, Phil. And when we look at it, I mean, Anurag, I think you've done some research and even done a security report. Can you highlight some of what you've done with PSA certified and take us through some of that risk and liabilities and what you're seeing there?
Sure, Win. Yes, we did a research with more than 600 decision makers within IoT industry, and then we drafted a PSA certified security report specifically to understand the challenges, bottlenecks, and problems the OEMs are facing regularly to implement security into their design of products. So I think we got some very interesting findings, and those goes back to what Carlos was talking about, the cost of inaction as well. In fact, the first thing was, I think about 50% of the respondents said that fragmentation of standards and regulation is a major challenge, which we were discussing previously. Another interesting, or I would say more worryingly, aspect was that, again, half of those were saying that they carry out threat analysis during the design of every new product. So which means that the best practices or best security processes are being skipped. And I would say this becomes a bigger problem with smaller organizations as only 1/3 carry out the threat analysis for their new products. And this exactly goes back to what Phil was talking about, the maturity of the organization. And another big issue which we found that, again, about 50% of the responders were saying that the using of external labs to validate their security robustness, which means that the 50% security weaknesses are being missed. And some of the other challenges which came out was around liability, time to market, cost, and lack of expertise and understanding. But majority said that they will include provision for root of trust in their products. And most importantly, I would say that almost everyone, and if I'm not wrong, I think it was about 84% of the tech decision makers showed interest in the development of an industry-led set of guidelines, processes, and standards with an intent to help them de-risk their approach to IoT security.
Yeah. So Anurag, I mean, when you look at it from that perspective, there's customers that seem ready and want to know more, but it's hard to figure out. And then you have customers maybe that are still in the we don't know what we don't know phase. So it's definitely interesting and, you know, kind of seeing how it's all going to develop. So I want to pause for a quick second right now. I want to address the audience and say, you know, in the Q&A chat, we're interested in your feedback. What's the biggest challenge with security for you and your company today? So if you could put that in the Q&A and just give us some feedback. We're very interested to hear what place you're at in your companies. So going back into the question and the follow-up on when we look at developing secure platforms and processors and chips, there's some development expense to having devices with security built in mind. Erik, from your perspective, of Infineon and Cypress, how do you see these costs? And, does security influence the device performance? And how are things changing with how parts are developed?
It's interesting that you talk about costs in that way. So I think what customers are realizing is that there is a financial cost to security. It has value, as Carlos was saying, obviously, I believe. But the other costs that customers have yet to wrap their hands around, and I look at a Fortune 500 company RFI about secure microcontrollers probably once a week. And they're getting smarter and smarter about the questions to ask. Where yet they have gotten to is understanding the performance trade-offs, I'll call them, or costs, right? So for example, I can take a standard microcontroller for a wearable device, and I can boot in X amount of time. On power on reset, I power up, I do some sort of ROM start, and then I can launch an application. Now we're doing security. So when you boot up, for example, every layer of the boot process needs to maintain a chain of trust. So the ROM boot would boot up and authenticate from a hash compare. The flash boot would do the same thing to a bootloader, and those are immutable code. When you have updatable code, now you bring in an ECDSA operation, and that takes time, right? So all of those things add time. So customers are yet to start asking, really, what is your boot time, or what is your time for this operation, or what is your time for that operation? They are starting to ask about some base cryptographic operation. They're obviously asking for hardware acceleration, but they don't understand yet entirely where that affects from an operational perspective, because there's sort of a blind, okay, you have hardware acceleration. Well, in certain cases, you really don't care about the accelerated piece. So you can do it in software, and you can have it upgradable, actually, which patchable is always good in security. But some operations, you really want the hardware acceleration. So there's a performance thing that I think folks have yet really struggled to kind of crystallize the dimensions of it and the impact of it.
Yeah, agreed. And, Phil, from Sequitur's perspective, when you come through and you're looking at these situations, how do you help these customers balance that cost and risk scenario?
So we start typically at the specification design. They've probably already chosen their silicon, and we work with them to cross all of the gaps. So hardware implementation, manufacturing, design, development, test, even down to the threats that the silicon provides. Because I'll be quite honest, the board support packages and software produced by most silicon vendors, it's rubbish. It's really terrible. What we see, the baseline for a lot of software developers and a lot of industries is just make it work and throw it out the door. So the amount of cleanup that we have to do and the education that we have to do. So we've done it so many times at this point that we have our standard set of tools and processes, and we walk that right into the door and hand it to the customer. And at the end, it's then preparing them for, okay, you're aiming for a standard. This is what you're going to need. And then at the very end is also line them up for probably even penetration testing. And hopefully it's a lab that's skilled, because there's a little bit of a frightening aspect of pen test is because they're hired as consultants, they feel they have to find something. But unless they're familiar with the stack or the system, they flag false positives. They're adamant that they flag vulnerabilities, and they don't like an explanation from a PhD on why they're wrong. It's sort of, so be prepared. It's complex, but at the end of the day, they're looking for a solution. You have to cross all of the gaps. All of them. And there's a lot of personalities to deal with.
Yeah, definitely. And as you kind of come through that, I mean, Anurag, we've heard right from Erik on the silicon side and Phil from the software and services side and how they're working with their customers. I mean, do you get a feel for like who owns the responsibility for making sure devices are secure, right? I mean, is it the OEMs?
I would start by saying historically, if you see OT systems were designed to be resilient and reliable and very safe. Whereas when you look into IT systems, they have been built to be more secure, private, and I would say reasonably reliable, right? So now with this IT and OT integration, end-to-end security becomes very, very important, which includes security at all various levels. You talk about application, you talk about device, you talk about software OS, or even at a silicon level with root of trust. With that, I would say that everyone in the ecosystem has got a role to play, whether it's a silicon provider, whether it's a software platform provider, or an OEM or an ODM. So in fact, now if there is a need to broaden the ecosystem by getting more players involved, like system integrators, regulators, industry forums or bodies, and even insurers, right? So this is, I would say, what we have been trying to do within PSA Certified. That is, we are working to align and expand the ecosystem. And personally, I would say that's the only way to solve this industry security problem is to build an ecosystem, as it's not a problem of one person, and I'm sure it can't be solved by an individual in the ecosystem.
Yeah, I mean, it makes a ton of sense that the ecosystem has to be involved, and you have all those links in the chain that are really going to be needed there. This is a great discussion that we're having, and I want to hit on a few more key questions, and I think this is going to be our speed round for answering, so that we can get a few more highlights in. So as you look through this next question, I'm thinking about from the perspective of how is this all changing the development cycle and requirements for OEMs and, devices, right? The customers, the folks listening on the call today are in those seats and, still have to get things to market quickly, have to beat the competition. I mean, Erik, maybe I'll start with you. I mean, are there significant skills gap in the security knowledge, and how are you seeing it with the OEM customers that you're working with?
We sort of look at two types of customers. So I kind of very high level say, and I'll try to be brief, but if you believe in 1 trillion IoT devices, 50% of those are going to be made by the big guys who have their own security teams. They have their own software. They won't actually take any software you provide them because they want to do their own software, right? And then you have the broader market. and the rest of the 50% of the trillion devices is going to be provided by the broader market. So obviously we high touch those large customers. We provide the hardware-based security platforms that they can then abstract everything they need for the use cases they serve to make the products they need and to be able to sell them in every market based on the regulatory climate. For the 50% that are the smaller to mid-sized companies, they struggle with having the resources because as everybody have said already, there's not enough of them. They struggle with the cost. They struggle with the time to market most of all, right? So, we just took a secure microcontroller and came out with a product line called PSOC 6.4, which has all the software, right? So the provisional software, the secure boot, the firmware updates, the isolated processing environments, the TFM for the secure processing environment, the cloud libraries to connect to AWS, stitched together with FreeRTOS, the cloud libraries for Azure, stitched together with FreeRTOS. It's like all of those things. So you can now hand your customer. So for me, it's an opportunity. For that broad market, I can now hand a customer not only all the hardware, but I spend far more of my resources in software than even hardware nowadays. You can provide them so they can get to market quickly with something where you can get them a configuration tool. When they're building their system software, they click a button, and the build system, like our Modus Toolbox, creates the image that is already pre-certified for them, right? So they don't have to figure it all out. They don't have to figure it. The certification applies. Boom, they get the market.
Yeah, it really does seem like, as silicon manufacturers are doing it, you're half hardware developers and half or more than half software developers nowadays, right? So
exactly.
Phil, from your perspective, I mean, realistically, how's it going to affect time to market for products and new, software and firmware releases in these trusted environments?
I want to respond to something Erik said. So the first is not all of the big guys, the Fortune 500, they don't have it. They don't necessarily have the teams. We deal with a couple of companies that have trillion-dollar market caps. And what they've told us is they could not get their products to market without us. They didn't have a chance. They're big, but they don't have the maturity. They don't have the process. They don't have the fundamental understanding of the hardware. We start, I mean, as well, that, if a customer has already done selection of a chip, we will give them hardware test cases for the security features that the silicon vendors never even run. We've cost some of our silicon partners millions of dollars in respins because they don't test adequately at the silicon level. Frankly, for me, that's terrifying. Putting one of those in a vehicle scares the living daylights out of me when I find features that don't work or a chip that's imminently hackable because it wasn't tested coming out of the foundry at die cut, or it was misprovisioned in the foundry. We've seen this too many times, and it's corner cutting, and it's a lack of discipline, and it's expense. So where all this leads is by providing a solution that goes from starts with the silicon all the way forward through design, manufacturing, development, test, life cycle. By crossing all of those gaps, our customers have told us we knock 40% off of their time of getting a product to market with the security features enabled. And I mean, without that, we've seen too many times where products go off the rails and they just fail. That's the scarier part of not doing this. And the companies, because I'll call it the other half that don't understand, if they go and roll their own, the likelihood of failure because they don't have the detail. They think they know, but go and read through a 10,000-page manual. Then go and write the test cases and carry that all the way up the stack and into operations. It's not a small problem. I mean, it's complex. Now take that, put it in an automotive context. Wow, how many hundreds of microprocessors and microcontrollers do you have? What firmware revisions need to go on those? What's the cross complexity of that system and the management and even applying an update to it? I mean, you now get into complexity management problems which start affecting security. So, think on that level and think at the process and the system level. And I mean, it all starts with a root of trust on every one of those devices. And how do you get that in and manufacture at scale and then make it economical?
Yeah, it makes a ton of sense, Phil. And, just wrapping up this question, we're coming close on time here. So I just wanted to see, Anurag, with the end users and end customers, how can we instill confidence, in what's been done with security and what's been implemented and, the process, right? How do you respond to these, new threats and new technology that are coming out?
Sure. So I would say it's all about establishing the chain of trust from a device to the cloud. And to achieve this chain of trust, we created an anchor, which is known as root of trust, which Phil was talking about. I would say, just to explain root of trust, it's a hardware protected part of the device that perform all of the trusted computing functions. And I would say this is now implemented by majority of the silicon partners, and OEMs are building their devices based on that. Yep. Secondly, I would say that PSA certified level 1 questionnaire is a living document which is continuously managed, maintained, updated, and refreshed maybe on 6 monthly time frame based on what industry is looking for, what industry needs are, what new threats are coming up, and what regulators are talking about. And lastly, when you see these OEMs, they get their devices evaluated by third-party independent labs and certified by a certification body. So I would say it's a stamp of trust and assurance provided by third party and not by the manufacturers itself. So I would say all of these definitely improve the customer confidence.
Perfect. Yeah, and I want to go to Carlos too. And Carlos, when you're thinking about it from a standpoint of the paradigm for designs and how things are going, should threat analysis and understanding risk, how does that affect that design paradigm and what customers are seeing? I'd love to get your quick opinion on this one.
Basically, that's easy because what I do is I take half of the answer from Erik, half of the answer from Phil, and that's the answer. Because
perfect.
One of the things that you see, and you're right, silicon vendors are way ahead here compared to the end devices. One of the promises we have in the industry is privacy and security by design. How do we achieve that? I have this story of one of the working groups working in one of those standards. Somebody suggested that for an IoT developer, one of the requirements was to use good crypto. And then I scratched my head because, how does a developer who doesn't is familiar with crypto because they use it, but they don't know what it means, is going to judge between good and bad crypto. And that's a really difficult problem. In the ideal world, we should be doing what Erik mentioned before. Let's, at the very beginning, when you're starting to design your product, when you are setting all the requirements, is this dimension, power consumption, etc., do your risk assessment, your threat analysis, see what countermeasures you need to have in place, make it part of your product development lifecycle, have your checks along the way as you develop the product. So when it goes to the end, it's there. That's by design. Of course, that's not always possible. There are some more constraints, etc. If that's not possible, the alternative is make use of best practices, make use of trusted components, make use of components that have been evaluated or looked by somebody else, because that already saved you some time. So you don't need to develop that capability by yourself.
Yeah, I mean, Carlos, I think you hit the nail on the head there. And, you know, as we kind of come through, I want to give our audience one more chance to engage with us on one more follow-up question. And so in the Q&A, if you guys don't mind, we'd love to know, do you have an active design where you could use help mapping these security solutions and the frameworks? Let us know what you're working on. It's definitely interesting for us, and you know how we engage and what we can bring forward for future panels and things like that. So we really appreciate it. One thing I'd like to do in our final speed round is we need to do a conclusion, and I'd love to go around Red Robin style and get one or two sentences of, you know, how do you get started if I'm doing a security solution or security-based solution, designing with security in mind. So I'll go ahead and I'll start with Anurag, and you know, if we can, I'll pump through everybody and we'll get a chance to do our final statements here. So appreciate it. Anurag?
I would say my final statement would be that it's an ecosystem play. So I think the most important thing here is to bring the ecosystem together, and everyone has got a role to play. So let's do that together. And if we think that if we can get the security right, the pie is bigger and everyone will get enough from that pie here.
Yep, absolutely. Erik, how about you? What's your closing thoughts here?
Yeah, well, I two things. One is I'm impressed with the emerging market of secure microcontrollers. We've come a long way in a short period of time, and it truly has been a team effort from the silicon providers to the software ecosystem. I think AWS and Azure, I'd like to thank them. They've really promoted security. They've invested in security. They've worked very closely with the chip makers. Because at the end of the day, we're the bookends. We make the chips where the data is captured and then initially processed, and then they do the back end. And so it's much better when we work together and just let TLS be TLS in between. So that's all goodness. And then to the other parts of the audience, from the regulatory and compliance area, I really appreciate what CSIP and PSA are doing together. I'd like to see, a lot of that. Benchmarking security assurance against the common criteria, AVVAN, JIL levels, 21 points, basic, enhanced, moderate, on all those different levels. I think I applaud them. They're taking the common criteria security assurance framework and making it more efficient for certification. So not 2 years, but 36 days, or whatever L4 becomes from a CSIP PSA harmonization of 55 days or whatever it is, and 25 points. I'd like to see that keep going. So if anybody can influence that, that's a good thing. Thank you.
Perfect. Thanks, Erik. Hey, Carlos, how about you for your closing statements? What are you thinking?
Oh, I just say thank you, Erik, for the sensitive PSA part. We are working on that. Now, but
let's chat. Let's talk.
Let's talk. Couple of things. I think we shouldn't be having this conversation about security. We need security. It's expected to be there, and there are much more than just compliance and regulation. Of course, that's a very important part. We know it's happening. A lot's happening, and Yeah, that's a fact. But then we have security that can help us for managing the risk. It's a great differentiator for OEM devices. Key takeaways: use best practices. We already mentioned some examples out there. When you are not familiar with those standards, you're not familiar with security, there is a lot of know-how out there. There's people who knows about that, who can support your designs. Whenever possible, make use of trusted components, trusted platforms, because that will also simplify the effort, will bring some time to market back to you that you can focus on the real tasks that are relevant for your devices. And definitely keep an eye on the standards, because again, this is something that is growing and we will see more in the future.
Perfect. Thanks, Carlos. Phil, last but not least, what are your closing thoughts as we kind of move forward for the audience?
I'm really hopeful. I look at what has been achieved in previous industries going back 20, 30, 40 years. There are a lot of lessons to be learned. And at the end of the day, this is people and processes, and security is an evolving process always. It's a moving target, and sort of fundamentally the way I look at our own business, hire the best you can, get the best resources, the best talent, the best skill sets, and be knowledgeable. And as well, admit what you don't know and get the help. And that's, I mean, that's hard. Sometimes that's very difficult to do, because if you don't know what you don't know, you don't even know where to begin to look to find the answer. So keep looking, but I'm optimistic. And I mean, everything evolves over time. Look where we are, look where payments have come to. Look at, even in the US, we now have chip cards. We don't have pins yet, but we still have chip cards. So huge step forward from the mag strip of 20 years ago. So I'm optimistic. We'll get there. It's just, there's an awful lot to learn from other disciplines, and look to people who have the experience and have been doing it for a very long time, because they've probably seen it before.
Yep. Awesome, Phil. I think that's a great way to wrap it up, and really, drawing on the experiences and what's out there, and really kind of investing in the security up front, so that your solutions are built with security in mind, and it's all there and it's not an afterthought. I want to really take a quick second and thank the audience for their time and attention. We really appreciate it. From Aero as a sponsor for the panel and the event, we really appreciate it. Go out and see more of the solutions and panels, and go learn about the security pieces and solutions that are out there. If you have any questions, you can hit us up at iot@aero.com to explore more about security and how to get started. We'd love to work with you and do more. I want to say a special thanks as well to our panel of experts, so Anurag, Erik, Carlos, and Phil. Thank you so much for your time. I really appreciate it. And everybody have a great day.